Good evening, all of you. My name is Mary Ann Chaco. I am the Social Sciences Divisional Coordinator, and you're here to attend the Social Sciences Divisional Seminar. Thank you so much for coming. I'm really happy to introduce Dr. Madhavilathi Maganti to this Social Sciences Divisional Seminar. She's visiting us from Krea University, where she's an associate professor of developmental psychology and cognitive science. And her work integrates both computational and behavioral approaches to study attention and language learning in infants and children. And she does this primarily by observing parent-child interactions. And another very fascinating aspect of her work is that she works with multiple Indian languages. And in fact, her work on early language acquisition and developmental linguistics aim to bridge the gap between linguistic theory and an understanding of how children acquire speech and language in a multilingual Indian context. And in fact, one of your peers, Stuti, has even worked with Professor Maganti in her lab for your internship, right, Stuti? Yeah. So a warm welcome to you.
Thank you so much, Mary. Thank you, everyone from the psychology as well, to all the faculty. It was great to see this place, this vibrant place, and very energizing to see all of you. A very warm welcome and good evening to all of you. I'm very happy to be part and to be sharing some of our research insights, especially in the area of infant research. I know infant research has been rather quite slow in India in terms of how we would actually try to understand this area of work. Though my work actually expands into infancy, early childhood development, as well as more towards the application of early childhood development as well. But today, for today's talk, I'm going to cover exhaustively about one of the ongoing studies that we are about to submit a lot more, and also talk a little about the other kind of research projects that we have, and also share why we do the work and how this work has implications, not only towards policy, but I will also highlight a lot in terms of the methodologies that we can actually use in terms of addressing some of these key questions that we want to look in. So much of what I would talk today would actually focus on some of this. But if you have any questions, do not hesitate to raise your hands. This is all totally for you guys. So just feel free to raise your hands. This is not like a talk, but rather a general class lecture kind of a thing that I feel, because this reminds me of the class that I've always had. So this is like more like a class in that sense. So I hope so. Even before we go into understanding this term of multimodal early experiences and all of that, that's kind of the little bit of my Twitter handle that says infant research on the move. So just that at one point of time when I was struggling to really get students to be interested in infant research, that was something that that actually what helped in terms of what students got fascinated with it. So I just thought that could be something that I will actually show you all about what got students' interest in infant research in some sense, in that way. So let's get started, because we have a long story to say and many things to actually talk about. I mean, just to start, when you heard of this topic, what was it essentially? Just to get my things in place, and also to just get a sense of what you all have in mind. What was this thoughts when you heard of this topic? And especially about, it need not be very specific to the topic, but also in general about infancy. What was your ideas? What came to your mind? We can just say whatever comes to your mind. What really got you thinking? Yes, very difficult to study. Yes, yeah, that's the challenging one that we do. Yes, anything multimodality. Yes, 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 yeah. Especially infants perceiving. So did you ever think about that infants were very smart enough? Yeah. Did you ever think that infants were as smart? Yeah or no? No. Okay, I see more no's, but let's see how smart babies are. So let's start to really think about what really and how do we study and what really is that. And so that's why what's going on in the tiny minds and what is it that we can really look into it and all of that. So the I'll have to. Is this working? Not working. I think I have to do it out here. I think I have my clicker. Then I can use my clicker. Wow. I don't speak clicker. Then I have my clicker. This is the clicker, I guess. No? This is the clicker, I guess. Okay, let me just. Okay. Why is this not moving either? Okay, think. Okay, so when this was basically my area of interest when I started, it was basically even from my graduation days. I was very curious whenever I saw an infant. Basically, it just used to always trigger my thoughts in terms of what is this tiny little creature here and how this tiny little one can actually figure out this world around and what's really going on. So this was something that was always fascinating, and I started off to really think that I should become an infant researcher quite a long time ago. And then that's basically though I was initially quite interested in genetics and all of that, but I thought genetics would very much limit my understanding of the human mind itself. So that's how I started to just get interested in this to really see what is it that's basically even in developmental psychology we start with this question about how the human mind basically with all its power and imagination is emerging from this tiny little creature which you see is so helpless, and you feel that yeah, how and within a span of 6 months, within a span of 1 year, you can see the kind of language they can acquire, the kind of cognitive task that is happening. So how is all of this happening is something very fascinating when you see an infant, right? You would just see just in 1 month that you could see so much happens, and that's the amount of how much that keeps going on in that sense. So basically, just try and see this. My clicker, so it gives me the. So today's talk basically will cover a little bit of the developmental research with infants and children, and then we will cover a little bit on examining the what is the multimodal nature. I'll explain what exactly is this multimodal nature. How do we study this basically through mother-child interactions and also through using some of the eye tracking methodologies in some sense. But also when we do this kind of work, there is also associated with related to neurodevelopmental assessments. Now, how do I use this kind of work to be able to apply
to the neurodevelopmental assessments, because we are all used to seeing standardized assessments, right? Intelligence tests that we are all familiar with, and we are all trained to be able to do some of that. But something with this kind of other alternate methodologies, how can we apply this for neurodevelopmental assessments? But I'm just going to just wrap up a little bit on policy implications, because all of this is something that's going to address a lot of these problems. So that's where you kind of, so let's start a little bit with what is developmental changes and how do we actually look into these developmental changes. See this child, basically, this is the baby at 6 months. But kind of take it out.
Open, close. Open. Itu. Open. Close. Open. Very good. Close. Open cheek, open cheek.
Okay. So this is the child, a little bit 6, 7 months. See, in this little child again at 9 months, 10 months, around that. And then
అరే ఇక్కడ ఎవరు కూర్చున్నారు కార్ లోపల ఎవరు కూర్చున్నారు అది దాంట్లో లేదా కార్ ఇదేంటి ఇదేంటి ఎవరి కార్ అది కార్ ఎవరిది కా ఎవరిది కారు ఎవరిది నా
so you can see that the same child, right? In the beginning, the child is also able to make out and being able to say that this is a car from a 2-dimensional picture that is there in a newspaper. So you can see that just within the span of 3 or 4 months, this baby he's able to open and close, but just still not quite in opening, but in that 4 months time, this baby is able to just see the car and then able to say. So how is all of this process is happening? So what's really going on? So that's basically what we are going to see. And that's where the aspect of when we say what is developmental research and why do we as developmental researchers are interested in this area of work basically is it provides us with this normative data concerning the quality, the limits, and also the capacities of the perceptual or attentional systems that babies or infants actually bring in. So anything that we want, because you see infants are not quite exposed to the environment as much as we are at 6 years or at 10 years. There is considerable environmental exposure that would have happened to children by 10 years. But if you see at 6 months, it's that much of environmental exposure. So really, in that sense, it provides us what could be some of those limits that could be there, but also get us this normative data where exactly the beginnings are in some sense. So developmental researchers so therefore, the beginning points for us is to also look and understand these sensory systems in terms of not only the structure of the sensory systems, like if you see the eyes, the touch, receptors or auditory receptors, the taste, the gustatory, olfactory, all of that, in your cognitive class, the sensory systems that you have looked into it, not only about the structure and function of all of this, but within that, how is this early brain development that's actually influenced by the kind of the stimulation, and what exactly is stimulation? What does it actually mean? And that's the perceptual world of infants, because the perceptual world of infants is filled with this sensory stimulation, sensory information that the child actually has to decipher, understand, because perception is also about trying to understand and make sense of what the information is, right, from the sensory systems. So how is all of that happening? So let's, even before we even try to get there, when we say something of an organism, what do we mean by organism develops, right? When we use the word develops, what is it that we say? the first thing when we say of develop or what it is, there is emergence of novelty. In the videos that you saw, from where the baby was able to just handle some of the toys, the baby was able to start naming a car. So you see there is emergence of novelty. There is something new that is acquired always that you would see that. So you would see emergence of novelty. And then the second is the complexity of structure that you could see. So the child is growing, there is something, the neurons, the brain, if you look into the neurological aspects, if you look into the behavioral aspects, there is some complexity that's already coming through. So therefore, you would see that development is something less from that's happening, right? The more complex that is going on. So you would see in terms, you would always see that there is emergence of something that's going on in terms of when we say there is change. So that's how, for developmental researchers, it's important for us to see what is that emergence of novelty and what is the complexity that's happening in some sense. And we know all of this is, and the first 6 years especially, and the first 1,000 days are especially very important, because the amount or rate at which the neuronal systems are actually developing, or also that we know that almost that the brain's structural as well as functional capacities are actually improving by leaps and bounds, right? There's so much of information. So the more the baby gets stimulated, the better is the neuronal one. So you see from the newborn to the adult, and especially at 2 years, look into it from newborn to the 2 years, see the kind of the connections, the synaptic connections that have happened. So all of this gives us a very good sense of how the baby's brains basically are developing, and every environmental experience that the baby has is contributing to this. And every second, every millisecond that you can see that is these experiences help in promoting brain development. And that's something that's very key and important for us in terms of trying to understand. So when we say emergence of novelty and also the complexity of structure, you could see the changes within the more neural, anatomical, as well as the sensory maturational systems that are actually progressing. And that's where we want to really see and also look into. So we do not want to miss the window of opportunity of the first 1,000 days of life in terms of trying to understand or look into what are those kind of measures or variables that can help me to predict later cognitive or language delays. Because we cannot wait till 2.5, 3 years to say, oh, this child is not able to speak, I should start intervention. By then, I said the first 1,000 days, where every second is so important for brain development. And if the child is not able to get any of that, or if some adversity were to happen during this early, most important period or more critical period, then it leads to lifelong issues or lifelong problems leading to any kind of disorders or disabilities. So that is why a large part of my work has been to really look into what are those measures or how we can red flag some of that. So I use this multimodal attention to assess this kind of cognitive and language development in, say, high risk and low risk. Low risk meaning full-term infants. So full-term infants are born between 36 to 40 weeks of gestation. That means they complete the 9 months of gestational period. But there are some babies who are born early. They're born between 28. That's when the fetus can actually at least can at least be the kind of problems that this is adversity, but at least in terms of the basic viability, this baby is viable, but definitely these are children who are at risk for other kind of later development and all of those. So therefore, these babies are also called as the high-risk infants or high risk. Not only prematurity, it could be other kind of problems related to prenatal, like it could also be as we won't say simple, but malnutrition could be a problem. Maternal diseases could be a problem. Maternal infections could be a problem. So there are many numerous factors. It could also be genetic or chromosomal aberrations. It could be chronological or any of those other kind of issues that could have led to any of these problems. So therefore, that is where, that's the key aspect of what I'm trying to address. And so I'll give you a little bit on why I use multimodal attention to be one of those measures, because at least right now, from the studies related to the low risk or term infants, we know that this early perceptual learning system is basically a foundation for the later perceptual, cognitive, language, as well as social. That means all-round development when we cover all of this. So that is why this kind of perceptual learning is very, very important. And so if we were to study this as a primary mechanism for how children acquire or how babies acquire knowledge, I'll explain to you why I say how do they acquire knowledge. I'll explain later in terms of how this is there. And so that it can help to red flag developmental delays, if any. We are there at the moment, but also the aim is to examine how this development of, we can call it multimodal attention or intersensory perception, but I'll tell you what it is. In the first year of life, that may cascade into atypical developmental outcomes or delays. We are still not there. We only have been able to collect some of the data related to multimodal attention and development of multimodal attention. But to really establish that, we need much longer, long-term longitudinal studies to be able to do that. So that's kind of what we are aiming for. So coming to basically, when I say what is multisensory environment, right? Because babies or infants, and even for us, we are constantly exposed to this visual, auditory, right? Touch, all of these are sensory systems other than the taste and olfactory systems, which are less, I mean, we talk about this much less, but auditory, visual, and touch is something that we always are actually bombarded with, right? Likewise, infants also are basically exposed to this kind of sensory stimulation, not only from in utero they are exposed to it, but when babies are born, mothers actually communicate. I mean, though we say mothers, it's also fathers, but it's also a limitation in developmental research, like you asked a question why there are limitations. You know, it's very easier for developmental researchers to study mothers because mothers are always with their infants, and so we always say mother, but also communication, parental communication, if you say. So when mothers are communicating with their infants, they always tend to provide a lot of any activity is more looking into objects, the objects making sounds, then they always are able to, so they actually know what is it that helps these babies to attend to the information they are actually talking. Very intuitively, they don't do it on purpose, but very spontaneously, naturally, a mother can make out what is it that the babies like, what is it, so they know how to embed all of these events, like moving of the toys that they know, how the sound they make. So that is how mothers actually, or caregivers, rather expose the infants to a lot of objects around them. So when mothers actually expose a lot of these objects, these babies are able to actually attend to this information. And now, what is it that actually helps them to attend to this information? That information is what we call it as invariant or amodal. Why I call it invariant or amodal, I will explain to you. So basically, when mothers are speaking to their babies, and naturally, even for all of us, when you are seeing me and hearing me, my face lip synchrony that is there is a kind of face voice that is temporally synchronous, that helps to recruit attention. And for babies where their attentional systems are not well developed quite early on, so babies' attentional systems basically are tailored to be able to attend to information which have this temporally synchronous. That is, when you actually clap hands, there is temporal synchrony. You cannot separate the auditory and visual information. Both auditory and visual information is happening around the same time. That is, it is temporally binded in space and time. That is what is called as amodal. Otherwise, it's actually called as bimodal information. If you see a dubbing movie, right? If the face voice synchrony does not happen, you're like, I can't see this. I cannot take this at all, right? It's like a movie, a dubbed movie. You won't be able to attend to that for quite a long time because the information is asynchronous. There is a slight time difference in when the auditory and visual information is happening. So that is this information which is temporally synchronous is also called as, this is the information that is always co-located and it is related in time and shares a common tempo, rhythm, and intensity shift. So it's everything. If you see basically when I clap, there is a tempo, there is a rhythm, and there is an intensity. I can do this, I can do this. So you cannot separate any of this in auditory or visual information. So therefore, you see that a bimodal synchronous information that you see how an event property, if you see any event, a moving of a toy, if I'm just moving this, it's just only unimodal, you're only seeing this. A silent movie is basically like, it's unimodal, it's only one modality that's happening. But if you see any information that is both you see, but there is a slight temporal gap, and then you see or you hear something that is called as bimodal information that you could see. So therefore, sometimes it is redundant. Redundant is basically one of the modality cannot be separated. That is why it is called as intersensory redundancy. And that's why we use the word amodal, bimodal. Unimodal is just only one modality. Just a radio is very unimodal that you would hear to. So therefore, amodal or modality specific that you could see. So these are the types of stimulation that babies are constantly exposed to. But most often, they like to see a temporally synchronous information. But later on, as they develop, they can attend to unimodal, they can attend to this dynamic information that is there. Even if I move away and I start, and you're only hearing to the recording without seeing my face, you can still see that this is so and so speaking. So if I'm interested, you are able to look into it, an auditory podcast. If you're interested in the information, you do attend to it. It's not that you cannot attend to it. But you as an adult have those brain structural, functional systems to be able to attend to that information. But babies cannot do that quite early in development. So that is why this kind of information that is tailored to meet their perceptual abilities is very important quite early in development. So that is where intersensory or multisensory redundancy, it helps infants to make sense of the information around them, whether it is information that's coming from the auditory, the visual, the tactile, vestibular, or proprioceptive. You know vestibular and proprioceptive, right? So that is available in the caretaking environment. You're always moving the infant like this. You're actually, right, you're singing to the baby. You're showing a lot of information to the baby. As soon as you see the baby, you like to swing, right? A lot of vestibular. So then you're actually touching the baby, so you can see the tactile and proprioceptive information that actually flows. So you can see constantly. As soon as you see a baby, you like to pick up the baby and tap and right. That's basically, and you start actually talking in what is called as motherings. You have a kind of, you elongate the phonemes, right? Ah, ooh, wow. Kind of elongations that we make. So this kind of phonemic infant-directed speech actually helps infants to attend to this information quite early in development. So that is where these babies, that is why you can say that if babies are able to detect this amodal events, that it becomes the cornerstone of all developmental processes. That is why you see babies learn about size, they learn about shape, they learn colors, they learn words, they learn about names of everything by 6, 7 months, 8 months. You can pretty much see how well the baby is able to do so much. So that's why you see that what we call it as intersensory or multisensory redundancy becomes the cornerstone for so much of cognitive processes that are happening with the infants. So that's why this amodal information is where babies are able to detect what is called as invariances. Invariances are information that does not change, right? Invariant. So they are able to detect these kind of patterns that are there, that's coming from the stimulation. So this stimulation that is available leads to perception, that leads to learning, that leads to memory, and then attention. So that is the information that babies attend to. That is the information where they are able to explore, and perception. So that is why you see that between attention and perception, do you see that? Okay, this is the information, and then you see attention, perception, and then it goes, and then this is the information that keeps coming here. Do you see that? Yes. So that is the constant information or stimulation that keeps happening. So that information or amodal information is the invariant. It unifies the kind of event that is there as a single event. And so therefore, it is a general perceptual phenomena where organisms attend to relatively stable patterns of regularities. If you have heard of the Gibson's theory of direct perception, right? Direct perception and indirect perception. In direct perception, you would hear about Gibson's theory, and Gibson's theory is all about being able to pick up that regularities that are there in the stimulation or information that is coming. So that is where this invariances coming from amodal stimulation or amodal information is where infant perception and knowledge are rooted. And that's where, which enables the infants to acquire knowledge about the world around them. And that basically is what creates this. So you can see that this is Goviti is being my postdoc supervisor, so it's her work. Then these are invariances. Invariances can come from unimodal, from multimodal, unimodal through auditory and visual information. Sometimes it could also be segmental through phonemes, and suprasegmental through the prosodic consonants, almost through the prosody that happens in languages. Ga, la, ha, ba, all of those prosodic segmentations that you can make. Then you have the multimodal one, which is also intersensory or amodal, which is temporally synchronous that happens. And sometimes both of this is spatially co-located. And you can see that voice and, sorry, I just call it as face-lip synchrony is almost happening within the same space. And even when I clap, it happens. But there are other ways of how these invariances are created. And I will tell you about arbitrary ones. These are more natural amodal information that is more natural. It happens naturally. But some of that information also happens more arbitrarily, means the pairing happens at the same time is when mothers keep naming the object and moving the object around the same time. It creates a unifying kind of an event. That is where it's called as arbitrary information, arbitrary amodal event that you would see. So that is how infants can make sense of this dynamic information that is coming through them in the world. So you could see where here mother says, take the fish, and this child starts squirming, and then the mother is taking the child to the lap and then showing the fish again. And then you can see that this is this continuous information that keeps on happening. So where from the videos, we actually were able to take the number of what we call it as video sequences. We did that. So this experience with multisensory redundancies is important for language development, and it helps in detecting who is speaking. They know whether it is a male voice, it is a female voice, whether it is the mother or father, so they are able to learn about the world around them. Then there is also this kind of information helps babies to also encode about the objects, and they learn the word object pairings. What I mean by word and object pairing, because when I say that this is basically a bag, or I called it as a pen, it could be called a pen, it could be called as a holder, it could be called anything for a baby, right? But what makes this called something that I can keep this, or for whatever reason I'm calling this. So these pairings that are very arbitrary, I'll tell you about it, but their babies have this arduous task of mapping all the words onto objects. So every object does not know that this is a chair. A chair can be of so many different designs, so many different colors. But why do we call chair as a chair? And why do we call pen as a pen? We are these crazy people, we ask these questions. And so this is, how do we know? And how do babies actually understand about this mapping? Because if a pen has to be called a pen, what are those properties of that actually defines it that it has to be called as a pen? It's very arbitrary. You could call it as a color, you could call it anything, but still babies are able to get to this challenge of being able to map words. You saw in the video that this child, just from the image of that car in a newspaper, a black and white, can see and say this is car, right? So you can just see that how that mapping, the child is able to see that these are the features that actually makes it to be called as a car. And even if it is not a three-dimensional one, it was a two-dimensional one that was there on the newspaper, but still the child was able to name it. So that's where intersensory mechanisms actually guides learning processes in infants. It actually is this coordination and calibration of all of this information. It glues and binds the stimulation across these senses, and it helps the newborn to turn to these AV events. AV meaning auditory visual event that we call. So it simplifies and organizes all of this sensory information for babies as a unitary event, so to say. So that is why this unified perceptual system is something to form a coherent and accurate understanding of this environment. And they pick up this amodal information and also attentional selectivity. They can attend. So selective attention, right? We always call selective. From this kind of information, why do you select a particular, and why do you attend to that information that you are drawn to? So that's why it is very highly salient. That means it is something, anything on a billboard or something that's there, right? Something that's moving always attracts your attention, color and movement. But something that there is some kind of an auditory and visual pictures actually helps you, right? If it is an auditory podcast, you lose your attention after a while. If it is like 15, 20 minutes of a podcast. You're like, listen for 5, 10 minutes and then your attention wanes. But if it is a video podcast, then you are quite attracted to that and you would be able to see that for that. So it is highly salient so therefore, for babies, the challenge is to actually pick up this information, maximize their attention across and make it coherent across time and space, and also pick up information and also minimize the pickup of that information that is irrelevant or incoherent. So they have to just be able to they only have to attend to this salient information, but all that information which is not salient or incoherent need not be picked up. So that is why it improves the efficiency of the perceptual system in terms of the cognitive processes. That is why cognitive economy makes sense when I started off, right? So you will see that. So therefore, this temporally synchronous, the role of synchrony is helpful in scaffolding infant attention to the object. So when mothers are talking, it's not only the mother's face. So when the mother and the babies are interacting during play, mothers tend to use a lot of this object-directed communication that they say. So if you see this, you will see how mothers name this object. This was from our experiment. We just called this Martian as.
I say cow, you say cow, 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 cow. I say cow, you say cow, 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 cow.
Gao.
Look,
The
cow.
Martian was called as Gao, so we told the mother to name the Martian as Gao. So you say, I say Gao, you say Gao, and I was, so instead of calling Martian, she's naming this Gao. So babies actually tend to it, and they are naming this to their pre-verbal infants, and that handheld object motion. So she moves that object and then says, Gao, Gao, Gao. So this is that movement that actually creates arbitrary invariant information. So it binds that information, like the face and voice is more natural, but this movement and this voice coming, they are not temporarily co-located, but still they are synchronous, arbitrarily binded. And that is what helps in scaffolding. So babies, I'll see why I am saying that it helps to scaffold infants' attention, and it directs infants' attention to the objects that the mothers are showing. So that is some of the work, and I will actually show you some of this. So that's basically how do babies learn words, and why I said I want to use multimodal attention, and why this is important for early identification of language delays is quite early on in development. You see that moms actually say, look at the cat. Look, it's a cat somewhere else that you could see. And then this cat basically is what the baby has the challenge of. Cat is that language, a phonemic sound called ka, has to be mapped on to some of these objects that, or an animal which has these two eyes and a tail and looks somewhat like this, is something called a cat. So this mapping of that phonics cat to this kind of animal that has these features that is there, that word mapping is what we call it as, it's called as word mapping. But we also have like word and event mapping, where what is eating meaning? How do you say, how do babies learn? But that's a different story. That's altogether, again, similar, but a little complex because objects have only one name, but for verbs, it's quite different. So the challenge is verbs are quite harder to learn. And so babies begin with learning nouns quite a lot. So, but how that happens quite early on and all that, we have other things. So words can refer to all of this that's salient or likely to be attended to information. So that is where you could see that this kind of salience that it creates. So out of so many number of cats, there is only one cat that so much of information that's available. This baby has the challenge of saying, oh, something that looks like this has to be a cat, right? You saw that in the video of so much of information in the newspaper. this baby was rightly able to point out only to the car that was there. This car was the one that the baby actually was able to look into it. And so you saw that how the baby was able to name that. So that mapping of this kind of word mapping that you can say. So to the object. So that is where we start about why pen is called as a pen or car is called a car or whatever it is. And how does that happen basically is through this process of multimodal attention or intersensory ones. So therefore, this is how babies, in some of this information about where we have looked through using head camera, what is the view of that object that the baby can see? How much of object can that baby see? What is that spatial information within that spatial information that the child can see? So all of these studies by Smith and Yu actually looked into what is that they're able to attend to. Because babies have to see the object and also attend to the sounds that the mother is speaking. So both of this are happening at the same time. But there is also that babies also at this time, they lack this kind of manual dexterity to hold the objects, right? And this hand-eye coordination is also very limited. Their visual acuity is very limited. They can barely see somewhat of the contours of those objects that are there because their visual acuity is not so much quite early on in development. So therefore, what is it that leads the toddlers or infants to attend to these named objects when moms are naming? So that is where you can see that as babies develop, sometimes their grasping actually improves. You can see there is an increase in grasping. So this baby at 6 months versus the baby at 9 months, the initial video that I have shown, you can see that between the 6 months to the 9 months, that kind of where the baby's dexterity skills were much better than at 6 months that you could see. So therefore, this grasping becomes quite much, and then they have a lot of skilled inspection on their own. As grasping becomes better, then it's not only mothers being able to show them the objects, but they themselves can actually explore and look into the object. They can touch the object. They can feel the object. They can visually see this object. So this kind of skilled inspection follows other than mothers naming the object quite early on. And as grasping becomes better, then inspection of all of this becomes better. That's how babies begin to map the words onto objects quite a bit. And you will see that there is a kind of, by 12, 15, 18 months, their language kind of improves substantially. And they're able to actually express and name a lot of objects around them, other than being, they can also say, who is this? They're able to identify, they can imitate, they can do a lot of things that's right. So does this actually mean that very young infants or environments are actually characterized by what we call it as referential indeterminacy? Because it's a very theoretical and a philosophical question, basically, because what happens is that nothing of this object's size, color, shape tells me that this needs to be called as a bag, or this needs to be called as some holder or something, right? So there is this, yet for infants, it's very easy for them to acquire all the words and language. So it's kind of this kind of theoretically, philosophically, the thing, it still remains about how this mapping happens. We are saying words are mapped, but the theoretical one is how does this happen still remains to be a challenge, because right now in this age of where we want to make robots, it's difficult to even have speaking robots who can understand even basics. But for infants, it's quite easy. You know, between the human intelligence to the artificial intelligence, it's quite difficult and challenging to really say that even speech detection for that matter in robots is quite difficult and challenging in that sense. So which is what for babies, quite easy, and it happens so that the determinacy that young environments are characterized, it's not the case. So that's where very young infants are likely to experience a lot of this word object coordination they just do it quite easily and effectively and efficiently because they start to learn all of this by caregivers. They can say who is mom, who is dad, what is mom talking, what's dad saying, who is coming, what is there, this size, that color, I want only this. Everything so easily, which normally is very, very difficult. It seems the process itself, when we really look, seems to be, oh, there is so much going on actually. But you see how smart babies are in terms of being able to do all of this quite well. So caregivers present always objects in synchrony. They always do. All of this has been actually studied a lot in lab experiments quite well. And that caregivers present objects in synchrony with their speech is quite well known from a lot of studies, especially the lab-based studies. Like I've seen. So they help in encoding, it helps in associating, it helps to attract attention. All this in term infants, we have seen all of this in low-risk infants quite well. It also promotes in object recognition that you could see that, babies can recognize mothers, fathers, any objects from their toys. They can do a lot of object recognition that is there. So it also does word referent associations or word mapping, so to say, word referent association or word object associations that they are able to make. They're able to map words onto objects. They know why a pen is a pen. They're able to map the word pen to pen very effectively. And if you show the 4 objects and I say, show me the pen, they will be able to take the pen and actually detect, right? They're able to do that very effectively. So that's why, but what we really see is that there are, within the naturalistic observations of mother-child interactions, whether if we have been able to find a lot of this within the lab settings, so we wanted to see whether in naturalistic observations, how does this process happen? So, and we also wanted to see what is it that is actually influencing infants' attention in natural kind of very unconstrained interactions, so to say. So that is why in our study, we used naturalistic mother-child interactions. We coded this, and we also wanted to see how is this process, whether mothers, when they are interacting with their low-risk and high-risk infants, are there any differences? Do mothers intuitively interact quite differently with their high-risk infants? So that was one of the questions that we had. And so that's where, just to go to sidetrack a little bit is, why do this high-risk infants show delays, basically? I told you that most of the information between the auditory or visual or amodal information that you said, or amodal information, depends on the maturity of these sensory systems. But for high-risk preterm infants, sensory systems are not well developed because they are born quite early. They're exposed to stimulation quite early. The normal in utero environment that these babies are actually in, they are hearing to a lot of mechanized sounds in the ventilator, right? They are in the ventilator, I would say. They are in the light in so much, which is not the normal in utero environment that these babies are exposed to. They stay in the, so these developmental delays could be because they're exposed to certain kind of environments, which is not the typical kind of the environments that newborn babies are exposed to. Newborn babies suddenly are exposed to human beings. They have their touch. Suddenly these infants are in this kind of ventilators. They have to listen to that ventilator sounds. They are not with their caretakers. Touch is not there. They're in those boxes. So you see that the environments are quite different. But that early environment, which is important for these brain experiences and brain's neural and entropical systems to be able to develop, still is quite different. So that is why we wanted to really see that what is this multimodal nature of perceptual experiences. Because in utero also, you see that all the sensory systems do not develop at the same time. You see that in utero, the earliest one that you could see basically the touch comes, then there is the olfactory and gustatory one that comes quite early, then hearing and language, and it is the vision that develops much later. So in terms of the time or temporality in how these sensory systems are developing, you would see that the time scale at which each of those develop sensory systems in even a term infant is quite different. So for this preterm infant or high-risk infant who is exposed to a different kind of stimulation, now this baby is receiving different stimulation. Now how that could affect the baby's brain or neural systems is still what we want to also understand. So that is why we also included this preterms as well as the term infants. And because there also have been very, very far fewer studies on at-risk or high-risk infants. Basically, most of the studies have been with, so this was one of the earlier studies where we did with 2-month-olds, 2-month term and 2-month preterm infants. This was published at least in 2018. So this is where we showed that babies as early as 2 months, especially preterm infants, are delayed in detecting this amodal information that is there. So mothers are able, so we also wanted to see what are mothers doing. Is it that mothers are not providing this information? That is why they are not able to detect, or why is, or where is it that's happening? So we've also wanted to see what are caregivers actually doing. From some of the very prior studies, we looked, and actually caregivers provide more stimulation to their high-risk infants than to their low-risk infants, technically. And then, which is not the case, where we think, oh, if the babies are at high risk, mothers will not talk to them, but rather mothers are more responsive. They talk to them more, provide more stimulation. But you see that the babies are less responsive, even to the caretakers' information. They may avoid the gaze, their arousal levels, they fall sleepy, then they start crying whenever mothers touch them. So any kind of stimulation makes them overwhelmed, and that's where babies, the kind of information. So thus infants born at risk may experience different kinds or amounts of synchrony in caregiver interactions, which is very different than the low-risk infants, and they have difficulties with it. So therefore, you would see that's why we used mother-child interactions and also looked into infants' attentiveness, and that because maternal interactions is what leads to infants' attention, and infants' attention is what leads to mothers. If babies are only looking or attending to mothers, mothers also start to interact more, right? If the babies or anybody who's interacting, we like to interact with people who are more responsive. If they're not responding, you're like, ah, okay, you just move away, right? So that's kind of where this kind of mother-child interaction. So therefore, we wanted to see if mothers of high-risk infants are actually adapting their interactions to match the infant's perceptual abilities or not. So we wanted to also look into if there are any qualitative differences that are there between the maternal interactions with their high and low risk infants in some sense. So we just recruited from Ram Manohar Lohiya Hospital, which is a tertiary care hospital, and then we had, that's the mother and child a little bit. So caregivers, we just had mother and child's interactions, and we videotaped these mother-child interactions and told the mothers to be able to speak whatever they speak. So they spoke Punjabi, Haryanvi, basically in Delhi a lot more of the slang on Bhojpuri from the region that they're in, the dialect of Hindi that you could see. And so therefore sample was 108 infants, 54 high risk and 54 low risk infants, and then they were preterm. The high risk infants were preterm, low birth weight is babies born below 2.5 kgs, or you also call them as IUGR, intrauterine growth retardation, or small for gestation age babies. They're born small even for the gestation, and also that if the infant would have spent 20 days or more in the NICU, they were there. NICU is neonatal intensive care unit. So these were the infants, and these infants were also screened for other developmental or medical conditions. And this was basically, don't look into this. The complexity of how much, when we said, how challenging it is. So this much level it took us to really recruit babies. For one baby to be able to recruit, this is the steps that we had to follow to be able to recruit a baby for each of those studies. So I just put that for that reason. Not there's too much of text, but why did we use this specific age groups? Why did we really take the 1 to 9 month olds? Because we also see that the attention preference and shift is more defined at these ages. Then changes in maternal behavior also you could see more during the stages. There is also a catch-up growth. And also we also wanted to track the intra-individual variability in development, because across ages between 1 to 9 months, what are the changes that are happening and all of that. So therefore we chose this age. And the procedure was we videotaped this mother-child interactions for 10 minutes. And these were the toys that we had given. We just kept the toys and videotaped the mother and child. And we told the mothers to just interact with the babies. So we also, after these video were there, we actually coded these videotapes. And we coded this for how much of verbal interactions, mothers talking verbal, mothers just only showing toys, and mothers making a combination of what is that, and mothers' use of synchrony. How much did mothers use synchrony? Were mothers able to use them? Because we have told that temporal synchrony is what helps infants to attend to information. So we wanted to see whether mothers are using synchrony in their interactions or not. So that is why we wanted to also give the use of synchrony that we call. So AV is auditory visual, AVT is auditory visual tactile. They also touch along with auditory visual, there is touch also happening. Right? So then the mother's use of gestures, like whether when mothers are showing the objects, they can make any kind of gestures. This is a shaking, they do sideways, they bring it top and up, they can use any number of gestures that they can do. And they also do a lot of this. So their infants, we also coded for infants' responsiveness and attention. So when mothers are actually naming and using temporal synchrony, we coded whether the infants are looking at the mother, whether they're looking at the object, whether their eye gazes are there, all of that. So all of this was manually coded. So almost all the 180, we had to reject a few babies. So that is basically auditory visual synchrony, where the object is actually moving and mother is naming. Auditory visual tactile is mothers also touch that object to the child's skin, and they actually keep moving and naming the object around the same time. So auditory visual and auditory visual tactile synchrony are the different types of synchrony that you could see. So basically in terms of the results, we had a different combination. So you will see the alluvial plot. So each of those verbal, non-verbal, and a combination of verbal and non-verbal, we had a total of 8,100 to be very specific. So we had 8,100 events across all the 108 babies. There were about 10,000, about 2,500 were uncodable. So out of which we had about 8,100. So you would see that alluvial plot where 2,000 and above combined, then you will see verbal, non-verbal, then whether synchrony is present or absent, and then you have the risk status as well as the whether the infant attention, they looked at the object, they looked at the mother, or they looked away. So this is the alluvial plot. These were the combinations of all the variables that we coded, and that's basically what we actually looked. So basically in terms of really saying, did caregivers use synchrony, you would see that if you would see that red line, which is the non-verbal bits, mothers used synchrony with non-verbal so much, but with verbal, they used much less synchrony. That blue line, do you see there? Can you see that blue line? Yeah. So the predicted probability. So yes, they used synchrony, both high risk and low risk. Across all the babies, moms tended to use verbal and non-verbal sounds, and they used a lot of synchrony. But basically, caregivers' use of all this synchrony, then you could see that the use of synchrony was higher with non-verbal bits than with verbal bits in some sense. So you see the blue color where it is present, synchrony being present in the blue color. So that's the other, a simpler version of the real plot actually. But there are subtle differences in how mothers use synchrony. So you would see that mothers of high-risk infants actually across age, that you would see that the differences that low-risk infants and high-risk infants, that high-risk infants is basically the blue and the red color. So you would see that caregivers predominantly use auditory visual synchrony more than they use AVT. They use a lot less AVT in terms of touching that they do, but they use a lot of AVT with their young infants and more likely to use it with the high-risk infants. That the moms use more of AVT synchrony with their high-risk infants because their attention systems are very, very low. Their arousal levels are quite, they kind of tend to fall asleep. So therefore, you would see that this visual, audio, visual, tactile synchrony is what helps to recruit attention. So moms seem to be using AVT with their low-risk, younger age infants and with their high-risk infants, even later that you would see that. That you would see basically. So that's see about 75% of predicted probability, but it declines a little bit across age. So that's where you will see that not that much how the. So did synchrony actually help to affect attention? Yes. So you would see that caregiver bids helped to also capture and sustain attention. In other words, with age, attention declines with age. There is better attention initially. So you see that the low-risk infants start to attend less to information, especially when synchrony is absent. When synchrony is present, they do attend. But when synchrony is absent, when low-risk infants don't attend. But something that's an advantage for in terms of the predicted probability that you would see. And there are differences between the low-risk and the high-risk infants in terms of how, and especially for the low-risk infants that you would see.
So consistently you see the same object throughout, right?
Not really, because it's the naturalistic observation set. Mothers could use any object, but the thing is they have to use it with any object. That's the only.
So this is not because the novelty of the object is gone, so the attention is going.
No, nothing of that sort. It simply just recruits attention across anything. That is there. So that's the basically one. So that's why synchrony promotes attention. But we also wanted to see, does it promote attention to mother or to object? Because there is mother space and there is object there. Are they looking at mothers or are they looking at objects? Because that is what is important for us in terms of how babies can encode these objects that are there. So that is why synchrony leads to increased attention to objects over mothers for low-risk infants that we would see. So babies who are low-risk infants, they tend to look more to objects, but high-risk infants tend to look more to mother space. They don't look to objects. We do not know why, but that's something that we have to look in. But that's something that we see, and you can see that much, that how the low-risk and the high-risk infants see the kind of attention and how these infants are looking more to the object and more to the less to the mother. So therefore,
explain this crossing, this blue line and green line.
yes. So in terms of the predicted probability, you would see that this blue line basically is where when synchrony is absent, then we have the red line is basically when synchrony is absent. Then we have the blue line, which is auditory visual, attention to auditory visual. And then you have the green one, which is the auditory visual tactile. So that is the predicted probabilities in terms of how babies attend to objects between the low risk and high risk. So this is a three-way interaction using the GNLER.
So at certain age, let's say 2.5.
Yeah.
The blue line is coming under the green line.
Yes, you see that there is a kind of an interaction that you could see, especially, and that is only with the high risk infants. Yeah. So that green line is where that auditory and visual, and also the auditory visual and auditory visual tactile, that actually increases for high risk infants. But for low risk infants, it's not as much that you can see. It starts quite well, but again, it's steady, it becomes steady after a point of time. As with age, it becomes steady. That you can see. So that is why synchrony leads to increased attention only for low risk, but not for high risk. High risk infants tend to look more towards more like the more towards the mother than to the object. So this is where this is more towards the how much is the predicted probability to the object. So we are only showing that object in that sense. So that is they start quite low if you see in high risk infants, but it increases, which is across age. But here it starts quite at more than 50%, actually at 60-65. But it increases, but it's steady. It becomes. But for high risk and also low risk, it's somewhat at the same level across age groups. But early on, there are differences. That is why this is more specific to the early ages at 1 month. So that's. So do high-risk infants experience less of word-object synchrony? I mean, we do see that considering bits in which caregivers use synchrony, young high-risk infants experience almost less of sound-object synchrony, we would say, because they're looking more at the mother than they're looking for the object, even though mothers are providing that. So this is largely because AV synchrony attracts low-risk infants' attention to objects, even from the youngest ages that you could see. So, but it does so in high-risk infants as only when they get older. As they get older, they're still attending, but they're attending much later than they're attending to quite early. So you would see that's why caregivers use synchrony with low and high-risk infants, especially non-verbal bits, and synchrony captures and sustains attention. AV synchrony is not as effective in promoting attention to objects, especially for high-risk infants. And then caregivers of low and high-risk infants don't use different amounts of synchrony. They use similar amounts, but we also wanted to see whether caregivers of high-risk infants are using AV or AVT synchrony to attract infants' attention, or they want to sustain infants' attention in some sense. So caregivers of caregiver bids in which synchrony was used, AVT synchrony use was higher when infants were already attending. So when infants were already attending, when infants already have attention, then mothers tend to use AVT more. So that is where you could see that when already attention is there, then AVT is used. When there is less of attention, AV is used. So you could see some of this. So caregivers of low and high risk infants don't use different amounts of synchrony, but caregivers of young high risk infants are more likely to incorporate touch into their synchronous bits. They may do so to maintain their infants' attention. That's it. So therefore, the conclusions basically are that this may eventually help to facilitate infants' attention to objects when they are labeled. That is why I told you word learning mapping that happens and when babies do all of this. So that helps basically in language development and object associations that babies are able to make. And so therefore, this dynamics facilitates also the shape-based object representations. The shapes of objects also are represented because the visual system actually is more tuned to actually more visual representation of shape than colors in some sense. So therefore, I mean, we do see that there are some differences with high-risk infants. So these differences, to what extent they will continue, we are not still sure, but they may contribute to some kind of learning or language difficulties later on in development, and which we already know that the preterm infants are at high risk for language or any of those problems later on in development. But how do they do this object representation or visual experience? It facilitates objects, shapes, and learning of their names because that visual acuity, as it improves, that from that low spatial frequency information that is there, it promotes forming object categories, especially shape categories that you can see. And this kind of this is where that fine-grained, the global reliance on those actual regularities that is there, that helps in the visual representation and how object shapes, how basically infants use object shape representation of visual objects in terms of word mapping that you could see. So they can name a ball, they can name what is square, what is, the color and all of those things. But our second question that we had was, I'll just take another 10 minutes. Is that okay?
No. We have only around 10 minutes left for 6 o'clock. Okay. So either we can pause here, take questions, and then.
Yeah, I'll just take another just 5 minutes for this one. This is like just an overview.
And then maybe we can wrap it up.
And wrap it up. Yeah. So in the second part of this, because we do not still have the results for this time, so I'm just kind of just showing what we did. The other question, okay, we know caregivers are doing something, and this is how the caregivers are interacting. But how much of this information is attending also we were able to do very much, but we technically also wanted to do it in a lab-based and also wanted to see how do at-risk infants are perceiving all of these intermodal relations that are there. And so therefore, how do they detect these interactions? What is the development that is happening? So we used an eye tracking to really track the eye movements. And we know that eye movements are very, very objective measures and very specific measures that can help us to understand about infants' attention and especially this multimodal attention. And so therefore, we hypothesized that at-risk infants may show this kind of attenuated perception to intermodal events, either because of their sensory systems or motor systems being immature at that time. So there could be differences in all of this. So therefore, our sample was 3 months, 6 months, and 9 months preterm and term infants. And you would see that this was basically where we used what is called as the multisensory attention assessment protocol. Click on this, I think probably you can't see this. Okay, can you see this? Multisensory attention assessment protocol. This was basically how we presented the videos like this.
I know a house. It's not a squirrel house. It's not a donkey house. It's not a house that you would see. It's not a.
So this is the video of the social event. One is, these two lateral events are basically, one is synchronous, the other one is asynchronous. So we wanted to see whether babies attend to the synchronous information or not, whether babies are able to attend to that information or not. So we use social and non-social stimuli. So non-social stimuli, basically of objects falling. One is synchronous and the other one is asynchronous. Social ones that you could see. So that's the actual baby you would see of how the baby is watching. So the eye tracker.
थोड़ा सा मैम थोड़ा सा नीचे करेंगे हमें आपको थोड़ा और नीचे
Calibration that happens initially. Also have a lot of interesting data that comes in. So we are in the process of
Distance is fine for them.
yeah, the distance captures. Yeah. We'll only after that calibration happens because
Now, are they able to see things at this
yes,
distance?
yeah, at that distance. Yeah. So that way they're able to see that. But so therefore we use all of this kind of the proportion of total looking time, all of that gaze fixations that we have seen. Yes.
What is the purpose? If we have one asynchronous one and a synchronous stimuli, what is the purpose of
The central distractor. So basically, we in the trials, the central distractor, the first 3 seconds are for attentional systems to regulate. And after the 3 seconds, that 10 seconds is what we use as data for that looking. But when the central distractor stays, it is called as high competition trial. When the central distractor goes away, we have it as a low competition trial. So we want to see whether babies are able to do attentively select from the information that's available. Like in the natural environment, they have so much information, but are they attending and detecting to that invariant information or not? That's basically. So that's why we keep it in lab conditions also. We try to keep it as naturalistic as possible. So we call it high competition. But that's also a challenge with the preterm infants also. So we are, at least the initial ones, we do see that there are differences in the proportion of total looking time between the term and the preterm infants, but we cannot draw any conclusions because this were just only 44. Right now, we have collected almost about 450 babies data. At 3 months, about 150. At 6 months, about 150 infants, and at 9 months, 150. So we are in the process of actually analyzing that data. So I cannot draw anything. So maybe the developmental delays in 1 or 2 areas of development is manifested due to intersensory impairments. We just have to still find out this in some sense. But once this comes through, I will be able to say. But eye movements, in terms of the neurodevelopmental assessments, standardized assessments are very difficult, and it takes a long time for us to do assessments, to be trained. It's very subjective also, it could be subjective also. But basically, we need assessments that are actually quick and enjoyable, that also wouldn't rely on language, not culturally tied to language. They allow for a deep data collection, and they are objective. And experimenters don't require any kind of certification and can be easily trained. They are portable and inexpensive. So actually, this kind of eye movements data helps us. And in one of the small babies trial that ICMR is doing, we have developed quite some interesting experiments to be able to test babies, especially 6 months babies, on visual working memory, as well as attention, selective attention, and all of that, spatial attention, and all of that. So we can use all of these cognitive processes to be able to do. And all this has implications for policy and future research. And so we are inclined more towards sensory-oriented computational models, neurophysiological studies, and conduct a lot on the developmental experiments that we do. And that's the small babies trial I was talking, and the many babies studies that we are part of. So we are part of the global consortium of developmental researchers. So we are also looking into theory of mind development on action-based systems in terms of how toddlers basically understand theory of mind and all of that. So that's one of the many baby studies. And we have actually contributed, we have 16-month-olds and 24-month-olds we had used in terms of the theory of mind. We just did. And then, of course, we are also doing into computational modeling from the eye tracking data that we have in terms of developing machine learning algorithm. Also to be able to do automated natural coding of child. What we did manually, we want to see if some automated computational modeling is available. So moms can actually take videos and they'll be able to make out how their interactions go, how it is, and what actually, so we could actually come with a lot more. We're also in the process of looking into the nears, or so that hyperscanning both the mother and the child to be able to get neural correlates when moms are interacting with their babies, other than behavioral ones. We can actually get neural correlates of what happens in terms of this kind of coupling that happens, behavioral coupling or behavioral synchrony between the moms and the child. We also have other studies on motion tracking where we used about when the mother moves forward, is the child moving forward, and some of those motion tracking studies that we have done. And I also do other kinds of work on actually early childhood development and capacity building and where we have been able to translate a lot of assessment tools into languages and early childhood interventions and all of this. And that's collaborators, Professor Jill Landy from Manchester, and Dr. Aarti Maria, who's the dean for the RML Hospital, and also my collaborator on this study, and Naveen, who's done a lot of this work. He's from Ashokam, and he's done a lot of this modeling work that he's doing for us, and a lot of other students. And my busy lab always, with a lot of students over there. And yeah, we were basically part of the APA's Spotlight on Researchers recently that we did. And then, of course, Saving Brains for Improving that. Thank you so much. I think this was quite long.
Thank you so much, wonderful talk. One quick question. The critical finding in the first study is that high-risk children are not able to attend to the synchronous event.
They are attending.
But not as good as.
They're attending more to the mothers. There are differences.
Not to the object, but
Yes.
to the mother.
A little bit, quite earlier, but later they started.
But if you just take the object, there is a clear distinction between low risk and high risk.
Yes.
Right?
Yes.
Is it possibly because of the lack of learning of the regularity? So the capacity to learn could
Yes.
be compromised because of
Yes.
the maybe a
Yeah.
preterm birth or
Yeah, it
something
could
like
be,
that.
it could be. That's what is our second question with eye tracking can help us to give us some bit of that.
It could be
It
learning
could be
itself that
learning
is
itself.
compromised.
It could be learning itself. Yeah. So that is why our first one was basically where we thought it is the caregivers differences in being able to provide. Are there any differences that mothers
Mhm.
in terms of the synchrony? But we don't see that.
Mhm.
Caregivers are providing that. But how much a baby is able to even pick up on that information, that's where the question comes. And that is where the second study where that lab-based eye tracking can help us to
Yeah,
understand.
in fact, you could locate it both at a sensory level as well as at the binding learning
Yes,
level.
yes.
So we
yeah.
really don't know where it is, where the
Where-
real problem is.
Yes, where exactly it is. So maybe with a little bit of this eye tracking
Yeah.
data that we are still doing, because we have data for almost 450 infants. We are just in just doing the data pre-processing and getting to create the pipeline for.
My last quick
processing.
question, how do you get so many infants? I mean, 400 is a very large sample.
It is a large sample, yes, because our lab is in the hospital.
Okay.
Yeah, it is a challenge. It has been almost like 5 years.
Okay.
5 years we have been, from 2019 onwards we have been collecting. So it took us 5 years to collect 450 babies. Yeah, and also this 108 babies from this waste things, yes. It's taken quite a long time. So yeah, developmental research is slow. So developmental researchers also publish slowly. So we are just about to, these manuscripts are in preparation, so we're just analyzing this data. Actually, yes. It takes a long time for developmental researchers to publish papers.
Any other questions?
One quick question.
Yes.
Your data, is it a kind of longitudinal in the sense that same child multiple times, and then you could see that how the intervention is working?
Yes.
Are you getting multiple data for same child?
Actually, our grant actually was supposedly, we had written a longitudinal one because longitudinal data is what helps us to really track the development. But then COVID happened, and then we needed that actual stretch of that complete 4 years to be able to get to where we wanted to assess child at 3 months, 6 months, 9 months. And then by around 18 months, we wanted to do the standardized assessment to actually look into their cognitive development and also see how this early, intersensory impairments actually lead to cognitive. Like all of that kind of we were not able to do because by the time we established the lab, trained the students, and then so that's when we said let's make at least a cross-sectional sample. That means we just took 3 months separately, 6 months, and 9 months. At least we can know what really is how it is going. So In the next study, hopefully if we get a grant now, that should be our next attempt. So that's why we were not able to address that second question.
In Indian context, that one is very difficult also, because there will be lots to follow up and other.
Yeah, a lot actually, basically. So it is a challenge to bring the parents to the lab and to also basically for them to agree to be able to do a lot of that. But since we luckily, that is why we established the lab within the neonatology department itself. So that is an advantage. So that itself took us almost like 3 years. From 2016 to 2018-19, my only thing was go to RML hospital and sit in front of their office to be able to see that we can collaborate with them. Actually, technically that's what we did. So establishing the lab, then getting the space, then testing and getting all of that, yes, there are practical constraints.
I have a question about parents.
Yes.
Because we have studies that look at the kind of stimulus-rich environments and social, and that it varies across class.
Yes.
So, and also there is the educational level of parents.
Yes.
Right? And in the way they think children should be brought up.
Yes.
So I was wondering if those are two aspects you consider
Yes.
in this research, class and parental education.
Yes. Because at least to the RML is a tertiary care hospital. So you can see almost like middle and lower middle income groups, basically, because it's a government run setup. So basically that's kind of what we see in this sample. We do correct that demographic data. And it's kind of uniform. Since it's a kind of the same population who comes. So basically that's what we do. But there definitely are these kind of the socioeconomic status and also parental education and all these factors into all of this. So if you see a preterm infant, if you take from any of like high income groups or upper middle income groups, most instances, if there are no other kind of comorbid conditions, you would see that a preterm baby almost grows like a normal, like any other child. Catch-up growth will happen. And you would only say that this will be a preterm infant. Right, but in a low-income setting, that's where these preterm infants and at-risk infants, it actually cascades because they are more prone to infections, more prone to health concerns. Then actually the stimulation is less. Then all of that cascades. And that's where early adversity leads to later consequences or adversity.
No questions from the students?
Yes, I thought you all had more. Either you understood or you didn't understand.
They should.
Yes. Thank you, Madhavi, for opening us to the very fascinating world. Thank you very much.
Thank you so much. Thank you all and thank you for your patience.